today, work on them for the rest of the week as we go towards the middle to the end of December. Okay, so we are on to our last two sessions. It's so great to have everyone continue to watch. Do keep bringing those questions into the chat so that we can talk with our different speakers and you can really dig into the projects that they are working on. But without further ado, let's introduce Loxley. Hi Loxley, how are you doing?
I'm doing great. How about you?
Very good, very good. I think it's early where you are and getting late where I am. So thank you so much for joining us on your early Saturday morning.
Yes, no problem.
We are very excited for your next talk because you are going to also be talking about things like classification and object detection, but using the Azure Custom Vision. And you have a bit of a story there. I won't ruin it, but I will say, let's go over to you. Do introduce yourself. We'd love to know a bit about you as well, but we'll let you take it away.
Awesome. Let me grab my slides really quickly, hit present. So hello, my name is Loxley Kolakowski. I'm a senior studying informatics at the University of Washington, and I'm giving my talk from the greater Seattle area this weekend. It's currently 8 o'clock in the morning. So my past experience includes internships at Microsoft and Accenture, and I'm currently interning at an AI startup called SiteWorks. And I also am the hackathon director for the Women in Informatics organization at the University of Washington. And my talk, Anyone Can AI with Azure Custom Vision, is for beginners who want to learn more about the AI solutions that Azure offers. But as I was making my talk, I thought that there may be a better name out there, such as an unexpected lesson in ornithology. And so you probably didn't expect to get a lesson in birds this weekend, but I guarantee you'll have some interesting technical and bird fun facts to share with your peers on Monday. But I'm first going to start out by giving a brief overview of what is Custom Vision and how I personally learned about it. And so I've had the amazing opportunity to participate in hackathons all across the United States, but no matter where I went, the winning teams were always deploying intelligent AI solutions. And whether that was smart glasses that could read a book out loud to the visually impaired, or a tool that could detect Parkinson's disease, these students were changing the world with AI. And what I quickly learned is that Azure was making it really easy for students to create these. Instead of education level being the barrier here, the only limit to what could be created was your imagination. And that is where the Anyone Can AI comes from. You don't need a PhD in machine learning to create your first working model. And so Microsoft Azure has solutions for all types of machine learning. But what I'll be focusing on in this talk is Custom Vision, Azure's image and object detection service. And as an extra bonus, it's low code, and for our demo, almost no code. So there is no skill barrier here either. So let's first cover how Custom Vision works. So since this is a talk for beginners, I'm going to give a quick primer to what artificial intelligence is in the context of Custom Vision. And so there are 5 distinct parts to any machine learning algorithm. The first is inputting the data. And so artificial intelligence is not inherently intelligent. We first have to feed it data and tell it what it should be looking for. And so a good use case to consider here is a self-driving car. We first have to collect data on like red lights, yellow lights, and green lights, and label them so the computer knows which image is which. And so the second up we have is analyzing the data. So after inputting the data, it is then analyzed by the computer. And so the data sets we will be working with today are relatively small, but you can imagine if an algorithm had thousands of images it had to analyze, this would be an incredibly time-consuming process. So next up is finding patterns. At this point, the computer has gone through each of the tags for images. And if we go back to our traffic lights example, it has probably realized that all of the photos tagged with the red light has the color red in it, and likewise for the yellow and green light images. And so next up we have is making predictions. And so after determining a pattern, the computer now knows that future data that follows the same pattern should also be labeled similarly. And so, for example, the next time a red light is fed to the computer, it knows it is a red light and hopefully tells the car to stop. And last but not least, is storing feedback. So this is the part where Azure Custom Vision and AI are just absolutely brilliant. After we have inputted the data, it'll begin training itself on the rest of the data it is then fed. And so over time, this will increase in intelligence and become a more accurate model. And so in short, data comes in, patterns are determined, and predictions come out that can be validated for accuracy by yourself. And for our demo today, we're going to do it on hummingbirds, specifically hummingbirds that are local to the Washington state area. And this is just a really fun fact I learned while creating this talk, but hummingbirds are only native to North and South America. And so we have 4 main hummingbirds in the Washington state area. We first have the calliope, which has these frayed red neck feathers. We have the black-chinned, which is uniquely purple in color. We have the Anna's hummingbird that also has the red neck feathers, but they extend to the head. And finally, we have the Rufous hummingbird, which has kind of like these greenish gold neck feathers. And disclaimer, although I'm a Washington state native, I have never seen any of these hummingbirds before in my life other than the Anna's hummingbird. And supposedly that is the only one that lives in Washington state year-round. And the great thing about all of these hummingbirds is that they're all relatively different from each other, so it should be no trouble for custom vision to tell the difference between them. So now let's hop to our demo and see how that goes. And so here we are in Custom Vision, and at this point I've already logged into my Custom Vision account, created a new project, gave it a name, and connected it to an Azure resource. And so for our demo today, we'll be focusing on image classification, where each image can only have one label. And so Custom Vision has domains for common use cases such as food, retail, and landmarks. But since hummingbirds don't really fall into any of those categories, we're using the general domain to train our images today. And so now, here we are in Custom Vision, but we're about to embark on the most time-consuming part of creating a machine learning model, and that is the data labeling. So to do that, we're just going to quickly hop into Bing and save the first 5 images we see of an Anna's hummingbird. Save image as into this file that I've already created. Save 1, 2, and then I'm skipping over this one because I'm not 100% sure that it is an Anna's hummingbird. Save image as 3, 4, almost done with this step, and 5. And at this point, we're going to go back into Custom Vision and add these images to our model.
Loxley, I'm sorry, I think you are sharing maybe the wrong screen because we're not seeing what you are doing.
Oh,
Just
thank you.
Yeah.
Okay, awesome. Let me quickly hop in. Sorry about that. I'm going to stop sharing again and then share again. Okay, is that good?
Yes.
Awesome, thank you so much. So at this point, we've added the images into Custom Vision and we're going to give them the tag Anna. And then we're going to upload these 5 files. And so Custom Vision needs about 20 images for each model. And so we've already, for the sake of time, I've already collected images of all of our other models. And at this point, we're going to hit train. And so there's 2 different types of training that Custom Vision offers. They offer a quick training and an advanced training version. For this one, we're going to choose quick training, but for more complex data sets, it's recommended to choose the advanced training option, even though it'll take a little longer to run. And so we're going to hit train here. And I've seen that it's taken about 5 minutes for these to train. And so for the sake of time, I've created an identical version of this, which has already been trained. And here we're going to run a quick test on it very quickly. And so we can browse local files, find test, grab a black-chinned hummingbird, and then it comes back as being 99.9% likely, so it's correct so far. Browse the local files again, grab the Rufous hummingbird, also coming back 99.8% likely that it's a rufous hummingbird. And now I'm a little concerned about our calliope and annas because they're the most similar hummingbirds of this batch. But the calliope is coming back 100% certain, and let's try with an anna's hummingbird. Try it with this one, also coming back 99% certain that it's an anna's hummingbird. But there's one last thing I wanted to test really quickly. And so let's try with this hummingbird, which I've intentionally labeled as a rufous. And it's currently saying that it's a black-chinned hummingbird. And so, like, why could that be? So I know that I always make data labeling errors when I'm working with Custom Vision, but I made this mistake intentionally. And the thing that I realized when I was first creating this demo is that this is an example of a female rufous hummingbird, and only male hummingbirds have the kind of metallic feathers on their neck. And so basically, what I realized is, like, these were the examples of all of the female hummingbirds. So here we have the calliope, here we have the black-chinned, here we have the annas, and here we have the rufous hummingbird. And so basically, the calliope, black-chinned, and annas are practically identical. And although this was accidental on my part, I unintentionally left out over 50% of all of these hummingbird species, which brings us to the main point I learned when first experimenting with Custom Vision. First is we need more data, more photos of hummingbirds to make our model accurate. And number two, we need to be mindful about how we're being inclusive when creating these Custom Vision models. And the great thing is that these two pieces go hand in hand. By adding more photos and practicing inclusivity while we do, our model would become more accurate of all the hummingbirds we say that we're representing. And so that was fun, but I think we have time for another demo. I wanted to give Custom Vision an even greater challenge. Could it tell the difference between a crow and a raven? And so in Washington State, we've had a very interesting phenomenon occur in the last decade. So a couple of years ago, crows started popping up like all over the greater Seattle area. And what we learned is that they roost at a wetland near the University of Washington's Bothell campus, and then they fly out in the morning and then return there in the evening. And it has gotten to the point where there's practically a crow strutting around on like every single block in the entire city. And so we know that Washington State has crows because they're smaller and have a pointier beak. But I went to Yellowstone National Park last spring and they had ravens, and you could tell because they have these more fluffier feathers around their neck and a more robust beak. And so let's see if Custom Vision can tell these apart. And so here we are in Custom Vision again. I've created a second model specifically for crows, and I've already saved all of our crow images. Go into Crow Vision, crow. I'm going to open these. Then we're going to add the crow tag. Usually takes a couple seconds to load these massive, like a whole bunch of high definition images into Custom Vision. And now it also, a cool thing is it tells us when we ever accidentally add a duplicate image. So now we've added in our crow images, and so now let's add in our raven images. Add images, go into Crow Vision, raven, and now we're going to add our raven images. We're going to give them the raven tag and then upload these 24 files. And once again, we're going to hit train on this. Click the quick training option and then select train. And once again, I tested this and it takes approximately 5 minutes, and I've already created an identical version of this that has already been tested. But before we run a quick test again, I wanted to draw your attention to these 3 main circles, and like what they mean and why they're important. So these circles are visualizations of how accurate our model is. So the first is precision, which determines how likely our model will be correct when it detects a tag. And so next up is recall, which is percentage of tags that it has predicted correctly. And the final tag we are looking at is AP, which determines the accuracy of our model at different probability thresholds, which you can change and adjust the probability threshold up here. And so I have found that a good rule of thumb is to have a precision above 90%. And if it isn't, I usually add more images, test it again, and then wait until it has hit the 90% precision threshold. And so now let's quick test with this one and see how it goes. I'm going to go into our test folder, add in a crow image, and it comes back as being 100% certain that it is a crow. So it's correct so far. Let's try with a second crow image. It comes back as 99.9% certain. Perfect. Now we are going to try it with a raven this time. Coming back 100% certain, and we have one more raven I wanted to try. And now this one is our first kind of mistake we've come across in our custom vision model, is it's coming back as 77.8% certain that it is a crow. And when I come back and look at this closer, we can see that our precision for the crow is 100%, but comparatively our precision with the raven is only at 83.3%. So, which we should probably add more data to improve the quality of this model, which ultimately comes back to our point of the importance of having more data and practicing inclusivity. So now that we've seen that custom vision can tell the difference between lots of different types of data that are even very similar to each other, but what is the use case for this? How can we share what we've created with other people? And so for this, we're going to create a very simple static web app with our custom vision model and a tool called Azure Functions. And so Azure Functions is Microsoft's serverless compute resource. And what makes serverless really cool is, unlike a typical compute resource, it only runs when we trigger it. And since it isn't running 24/7, it is really eco-friendly and cost-effective. So to first make this work, we're going to go back into custom vision, go into our bird vision model, and the first thing we're going to make sure is that our model has been published. And after doing that, we're going to hop into settings. And so in the settings tab, we'll see all of the information we need to create an Azure function. And so I've already taken this information and used Visual Studio Code to write and deploy a function to the Azure portal. So I wanted to quickly highlight a few key pieces here in the Azure portal. So the first thing are these 3 lines, which is pretty much like after publishing our tab, it gives us these settings to the end key, which gives us access to the custom vision service. And then the second thing I wanted to specifically highlight is this kind of our logic, which probably looks relatively familiar. We're basically running an if-else function where if it detects either an Anna's tag, a Blackchin tag, Calliope, or Rufus, it'll return the following message. And so we can test this out really quickly with this test run service. And so basically how this is currently working is this is the type of serverless function, which is called an HTTP request, because when we submit an HTTP request to the server by changing the URL, the serverless function is triggered and sends back a response. So let's test this out really quickly. What we're going to do is we're going to add a parameter here, and we're going to give it the name URL, and then we're going to find an image of a hummingbird and copy its URL, its image link. We'll enter this here, and then we will take out the body, and then we'll hit run. And then our quick test does that this accurately came back as a Calliope hummingbird. So this is currently working really well within the Azure portal. Let's try to do it in a static web app now. And to do that, we're going to get function URL and copy this following code. And now we're in our static web app. And the first thing it tells us is an image URL is required. And so to make this work, we're going to use the following syntax. We're first going to add a question mark, URL and then equals sign. And then we're going to copy and paste an image of a hummingbird, copy image link, and paste it in. Hit enter. Our serverless function has just been triggered and it returns back, this is a Calliope hummingbird. And so let's try it again with a Rufus hummingbird this time. Rufus hummingbird, like this photo, copy image link, everything. And now at this point, we've already added our question mark, the URL and equal sign. So we'll be changing everything after the equal sign. We'll enter in the Rufus hummingbird. The serverless function is triggered and it returns back, this is a Rufus hummingbird. And so now let's try again with the black-chinned. We'll try, let's see, I like this one, copy image link. And once again, we're changing everything after the equals sign. This is a black-chinned hummingbird. And finally, we'll test it one more time with an Anna's hummingbird. Copy image link, change this equal sign right here. And it returns back, this is an Anna's hummingbird. And so here we have it. We have a static web app that could be accessed by anyone in the entire world right now, which is just super cool. So now let's go back to our PowerPoint. And so basically at this point, like the next steps I have to take is to flesh out the website so it's a little easier for someone to interact with so they don't have to actually manually adjust the URL to make the serverless function trigger. But hopefully that will be the next talk. And so in conclusion, I hope that you see that the only limit to Azure Custom Vision's power is your imagination. I hope you see that birds are only the beginning to what Custom Vision is capable of. And so my question and call to action to you is, what will you build? And finally, whatever awesome thing you create, I would love to see it. Tag me on Twitter with what you create. And before we end, I wanted to direct you to some great resources that have personally helped me learn these technologies. So the first is just Custom Vision AI, so you can test it out yourself. The second is a Microsoft Learn module where you can learn to create a model that classifies images very similar to what we created today. Second up is a Microsoft Learn module that can help you learn how to detect objects within Custom Vision. And then finally, I have a link to the Seasons of Serverless Challenge by Microsoft, which is how, if you're interested in Custom Vision, serverless, and Azure functions and combining them all together, it's a really great challenge to be participating in right now. And so thank you so much for coming to my talk, and I hope that you learned something new about the awesome world of Azure and AI today. Thank you.
Thank you so much, Loxley. That was really a cool talk, and you managed to pack so much into 30 minutes, including Azure functions. That was, I mean, amazing. There is one question we have in the chat. So somebody is interested what happens if we give custom image the image which contains no birds or no hummingbirds, like what would be predicted for such an image?
Man, that's such a good question. And I feel like that's just me. I have to add more data to the custom vision model. Like, oh man, I want to test that so much right now to see, like, if I just added a random image, what would it say? I'm guessing it would just not detect any tag in the image right now. But if I added more images of like, hey, this is not a bird, this is a completely different species of bird, I think that would add a little more to it. But if I were to guess right now that if I tested with just a completely random image, it would just come back like no tags detected. And so how that would affect like in serverless, not 100% sure.
Yeah, I think you are correct. I think we did those experiments, and if it contains nothing really similar to the bird, it just gives 0 probabilities to all classes, which means that it's not purely a classification model. It's a classification model which can also have the class for no detected objects. So there is an interesting question. I think you mentioned that there is no limit to custom vision, but custom vision is really easy to use. But in some cases, you still prefer to train your own model. Like, for example, in the previous talk by Nigama, she showed us how to train TensorFlow model, which is a more complex task. So do you think there is like the pros and cons for using custom vision or training your own models?
Yeah, man. That's also such a good question. I feel like one thing I've seen with Custom Vision is with that, I think maybe would be a beneficial by creating your own model is, man, I'm trying to think how to exactly phrase it, but I've noticed as I've personally used it, it's like once you get to a certain point, as I was once creating a model like last February where I was adding in like every single letter in the alphabet, and suddenly you're dealing with like thousands of images. And I feel like something like that could be automated in TensorFlow to be significantly easier to create. But that's just my current like feeling is like maybe in the more like simple things, it makes more sense. Or maybe if you only have like 10 tags, but once you get into like the maybe a self-driving car where you have to detect thousands of different things on the road in real time, suddenly using it might not be the best option in the world, and there might be a more like, yeah, TensorFlow would be make more sense in the situation.
Yeah, actually, one point here is that you can automate Custom Vision. Because it has an API. So if you want to upload like many objects, instead of doing it manually, you can do it also programmatically. But Custom Vision, technically, it contains the machine learning transfer model behind it. So there is a pre-trained neural network and then some classifier trained on top of it, which is like a very clever way to do it. But it is not like it. The original neural network, the CNN, is not being retrained fully with Custom Vision. So it means that for typical objects, it would work like very nicely. Like in the Custom Vision, when you start your model, it asks you, what are you going to classify, food or like general objects? And there are a few options. So for those kind of options, it works pretty well. If you have some very specific objects, like I don't know, some tools or something which is not common, then it might not work as good as your own TensorFlow model. So there is still value in training your own models, even though it's much more difficult. In my experience, I mean, I've done some projects with object detection and with object classification, and we always started with Custom Vision. Like we trained our first model with Custom Vision. We saw like how much accuracy we can achieve, and then to improve it, we retrained our own model. And typically, it was a little bit better, but not significantly better. Also, Custom Vision, you showed us that it can work through as a web service, right? But there are cases when you might want to run it locally. Can you run Custom Vision models locally, or is it only like a web service?
I'm fairly certain you can run them locally, but I'd have to do more experimentation with that. Even the first time, it's actually, I think the first time I've ever deployed it to an actual like public website was like for this talk. And so everything I've done previously has been completely local to my computer and just using it within like the Custom Vision portal. And so I think it's definitely possible, but that's like more experimentation on my part to figure out how to implement that specifically.
Yeah, that's an important thing to I think to remember, that cognitive services, we all often use them as a web service, but in fact, most of the cognitive services can be also deployed in containers locally. So the fact that that you need sometimes the local model should not stop you from using Custom Vision. And also, by the way, Custom Vision has a great feature. If you train you can select the mobile version of the network. Like when you start your project, you can say, I want to train the mobile version, in which case you can download the actual model from Custom Vision and use it locally on the mobile device. So it's really, Custom Vision is really such a cool tool indeed. So yeah, thanks a lot for sharing this. I mean, that was really a great overview of Custom Vision. And by the way, you showed the object classification task, right? When you be determining the bird species, but you can also use that for object detection task. Did you have a chance to try it for object detection?
That's like the next step I have. One thing I wanted to try to do is to get an image of maybe like 20 hummingbirds at a bird feeder of different species, and then specifically tagging each image with the type of species it was. That's like, I think like the next step in my personal learning journey. And in that case, it would be very more, I feel like at that point you could actually like create something where you could take like a video in the lifetime and it'll detect where the hummingbird is in the video. So creating that is definitely like the next possibility. It would be a little more time consuming on my part, but it would be a super unique project.
Exactly, and you would be able to solve tasks like counting birds in the videos, and that is,
yeah.
I think there was one nice project described on the Microsoft website as the case study when they trained the model to detect and count endangered birds. And the main idea there was that to come up with a data set, they used the video. So from the video, if you mark up the first frame, you can try to track the birds automatically. And there is a tool called Visual Object Tagging tool by Microsoft, which helps you to do that. So you don't have to mark up like thousands of images separating birds individually. You just mark up the first frame of the video, and then you have the huge data set. You can train the model. Okay, yeah, thanks so much. That was a really nice example of custom vision, and everybody who faced the problem of image classification or object detection, that's the first place to go and try customvision.ai. Thank you, Loxley, and
Thank
the
you.
next. Thank you. The next panel.